So if this is your first time coming to the North Bay Discovery Day, welcome. This year, of course, we are virtual. If this is your first time here, we just want to give you guys, everyone on the call, a few what we're calling rules. So first off, you can go into participants and you can hover over your name and you can rename yourself with your first name only. And we're recommending you do that because this is being recorded and that just keeps everyone's privacy nice and safe and secure. You can write in the chat if you're having problems with that. We also ask that you keep your video off, again, because this is recorded and it'll just keep our videos from lagging so everyone can see us in real time. Also, please stay muted unless we ask you to unmute. That way we don't have crosstalk. And then this is going to be a question and answer session. So please, while we introduce our speakers and our panelists, please go into the chat and type in your questions, and I, as the moderator, will be going through those questions and I will ask them for you to our panelists so that you can hopefully get your questions answered. We will have about 55 minutes for this session, so we can't answer every question, but we will do our best to answer as many questions as we can. And then also there's a raise your hand feature that you should be able to use as well. And again, I can let you know if you want to use that, but that should be in your Zoom link, okay? So again, if you have questions for the speakers, if you're having technical problems, put those into the chat. And without further ado, let's get started here. So as you should know, we are all from Science Says. That's a group at UC Davis of graduate students and postdoctoral researchers. So we are scientists and we all like talking about science to people like you. So we're very excited to be here today. This is my 4th year at the Discovery Day, so I'm very excited to be virtual. And again, type your questions into the chat. A quick about me, the moderator. I am a strawberry flavor researcher. I will be a panelist at 5 p.m. if you want to learn more about me. I work at the breeding program. And then I'll give it off to Gabby.
Hi, everyone. I'm Gabby, and I am a first-year PhD student in the plant biology graduate group. And my journey as a scientist started a bit later than most people I know. I had a career as a florist and as a greenhouse manager for houseplants. Also during that time, I became a mom. You can see a picture of my 3rd grader, Ethan, on the slide. And I've also included a picture of my awesome dog, Cornbread, just because most people love dogs and I thought you might like to meet her. So plant biology is really important. I think it's really amazing. And I don't know if you guys know this, but plants are actually amazing chemists. So I think of plants as like the best chemists on the planet. And plant chemicals are really important because a lot of our medicines actually come from plants. Biofuels and bioplastics can be made from plants. I've learned recently about plants that are being used to fight climate change and other global issues like that. And of course, our food comes from plants. Even if you're not a veggie lover and you're a carnivore, even those animals have to get their energy originally from plants. So my goal as a scientist is to study plants, specifically study plant chemistry, and kind of try to understand and unlock the secrets that plants have as chemists. So we can tap into some of these chemicals and improve our medicines and biomaterials. And so feel free to ask me any questions about being a plant biologist, being a graduate student. You can ask me questions about my dog or whatever else you can come up with.
So this is my slide here. My name's Cassondra, or Cassie, whichever is easiest for you to pronounce. And I'm a material scientist. And currently I'm in this chemistry lab and I'm working on basically building electrochemical cells that can make alternative fuel. And this alternative fuels is all part of this energy science, which I talk about here on this slide, which is essentially work in any type of field, including chemistry, material science, even biology, physics, many types of engineering, where we're working towards building and creating things to solve energy problem. And it's everything from electricity to batteries to wind power, making solar cells, things like this. And so, there's a lot of different sides of that. And this is actually kind of what I've been doing. And I'm producing this black goo here, which essentially, this eventually becomes a powder, and then it goes into an electrochemical cell like this, where it's producing hydrogen gas, and that hydrogen gas can be used as a fuel for possibly cars of the future, or to replace coal and to replace gasoline to clean up our planet. And this electrochemical cell, basically all you need to do is add my catalyst and a little bit of vinegar, and then boom, we have hydrogen. So this is a new technology that may grow and really start to help us out cleaning up the planet.
Should I go now, or do you have something to say first, Mary? Good? All right, cool. So I guess, where should I even start? Hi, everyone. My name is Jess Trinh. You can call me Jess, that's fine. I don't really have a slide, but I did want to show you this virtual Zoom background that I made to basically illustrate the stuff that I do. So I am a third-year microbiology student at UC Davis. Microbiology meaning I study microscopic organisms. That's viruses, bacteria, fungi, you name it. If it's smaller than a few microns or you can only see it under a microscope, that's what I'm studying. So what I like to focus on is this interaction between plants and microbes. And it's interesting because, well, plants can get sick also, and they don't sneeze, they don't cough, they can't get COVID-19 like people do, but they can start to wilt or yellow or produce less fruit when they're sick. So it's really important for us to understand these diseases so that we don't lose our food, because we grow all of our food. Animals eat vegetables, people eat vegetables. If you have a favorite fruit, chances are it's probably getting infected by some sort of disease. And I've kind of illustrated that here. So on the left side, you get a healthy plant and it gets infected by all these sorts of little critters, and then they become kind of sick and sad. So that's the kind of stuff that I study. And I like to study the particular interaction between them, see why the plant gets sick from the microbe and why the microbe tries to attack the plant and how the plant tries to defend itself. So there's this constant interaction, this constant battle between the two that I'm trying to untangle those relationships in. And you can ask me anything about that sort of relationship. As you also know, this background I made myself. So you can also ask me about hobbies that I do. I draw, I sew, I do a little bit of arts and crafts. So if you are interested in that sort of thing, let me know. I'm really happy to hear about it. And I'm really happy to try and combine crafts and science together. So that's kind of my thing too.
Awesome. Thank you, speakers. So at this point, this is the Q&A. This is where we want to hear the questions that you all have for us by typing those into the chat. And then if there's an opportunity maybe for a follow-up, maybe we'll ask you to unmute. So type your questions into the chat, but I will get us started. This was a really popular question in our last session at 1 p.m., which was, what is your favorite part about being a scientist? What got you into science? Any one of you can start.
So for me, I think that I kind of loved science my whole life. I remember being in second grade, and we would play this game on the playground where we were all superheroes. And my superhero that I was just called Dr. Science. And we had this rule that I have this water bottle with glitter in it. And if I shook it up, then everyone would pretend there's a hurricane happening. And I always had this idea that, if I could learn how to do science and work with these chemistries and these laboratory things, then I could make a big difference. And I am, and now I'm here and I'm doing it. And I went through school, and now I'm working on this great technology, and it's been very fun.
I think I'll go next by saying that I grew up helping people a lot with their homework. And I really enjoyed telling people, helping people solve problems. If they come to me and they're I don't understand plant biology. And I would say things like, oh, okay, like I liked explaining these little details. I liked helping people understand these really cool concepts, because there's so many aspects of life that you can't really understand until you like really look at it from a really specific picture. And I just think that's really interesting. And I think what really inspired me to pursue science and study it is because I wanted to A, figure out what these little puzzle pieces are, and then B, share that with people, because I really want people to understand and know about the world around them. That's kind of my motivation.
So I decided to be a scientist because I really love asking questions. And as far as I can tell so far, science, I can continue to ask questions until the day I die, and that'll be okay. I'll still be a good scientist and I'll continue to learn and grow. And then I also agree that science is a really great way to help people, because there's so many things that we can learn from the world around us that can just help us be better humans on our planet and help each other out.
Awesome. So we have a question from Natalie. I just asked Natalie if they would like to unmute and ask it themselves. Otherwise, I'm happy to do so. We'll give Natalie a minute to decide.
Okay, I'll unmute. This goes for all of you. How did you know what you wanted to study?
That is a great question. I really hadn't refined it for a long time. And then I was in high school and I took my first material science class. And in it, we did these great experiments where we were trying to come up with a new composition of cement that will like hold better and like be stronger and have different properties from your average cement. And I remember working on it and thinking like, well, this is really cool. Like I can make something from scratch and like kind of mess with what it's made of and get something new. And that's kind of when I fell in love with it. And then from there, I went on to build batteries and like make the little parts that go in batteries. And I was like, oh, if I could do something with energy, that'd be really fun. And that's where I'm like figured out that I wanted to work with the energy side of science. That's a great question.
Natalie, I also think that's an excellent question. I guess when I first started undergrad, I really did enjoy life sciences in general. I just didn't know what I wanted to focus on. I really thought I was going to be a doctor, like a medical doctor, when I started undergrad. And then I joined a research lab because I was like, well, it's kind of important to learn the scientific process to be a doctor, because doctors are doing things based on the scientific method. So I joined a research lab, and this research lab happened to be in microbiology. They're researching soil microbial ecology, like what microbes are doing in the soil. And I was like, why is that important? I was just out of high school. I didn't know why they were important, but I just learned that these tiny microscopic creatures can be responsible for like taking a bunch of carbon dioxide from the environment and shoving it into the soil, or like breathing out carbon dioxide and then releasing that into the air. They are responsible for like overturning a bunch of nutrients in the environment. I thought that was amazing. I was like, these little critters really do that kind of stuff. So I just got really interested in microbes in general. And I guess I've been passed around multiple research labs. I've done a lot of things like biofuel stuff, plant stuff. I think what really got me interested in this particular research was that this is a very challenging problem. Plant diseases are actually really difficult, as human diseases are challenging to work with as well. And this particular problem that I'm facing, which is a citrus disease, the pathogen itself, the bacteria that causes the disease, is very, very complicated. And I was like, really? I like complicated. I think that'll be very interesting to try and tackle. And yeah, many people in the world are tackling the same disease and are also running into the same hurdles. So I don't know, I just thought that this particular project is like unique and interesting, and it's an interesting problem to tackle.
So for me, I didn't know I wanted to be a scientist for a really long time. And I really love flowers and plants, and I had a farm, and I knew, I just love food and plants, growing, even just for hobbies, growing plants. And then I realized that I wanted to know more. And so I started reading books, and I, taught myself a lot about like gardening and things like that. And I kept wanting to know more. And I was like, wait, but why do they need these nutrients? And why does this sunlight affect them in certain ways? And I got to the point where I couldn't self-teach anymore. And so I was like, I need to go back to school because I want to learn more about these plants. And that's where I fell in love with biology. And then through my biology degree, I started falling in love with chemistry. And it was too late to become a chemist in my degree. So I studied them. I worked on a chemistry minor as well in undergrad. And I became fascinated with chemical synthesis in organic chemistry. And then I realized that like, plants are making some pretty cool chemicals too. And the more I looked into like the chemicals that plants were making, the more I realized that there's a lot of unknown. Like our chemists are pretty darn good. Like we have some cool chemists in the world. But when you look at what plants can make, like we still don't understand any of it. And so like plants are, they have tools that we don't even understand yet. And so that unknown, again, it's just like wanting to know more and wanting to ask more questions has really just fueled me.
Yeah, and they, from them, like pivoting on that point, plants have this great, like it's years and years of like evolutionary design. And there's a lot of things that even what I'm doing is based on something that happens in plants already. And we're just trying to build it ourselves in a lab, like in a man-made way. So yeah, plants are like the coolest teachers as well. Totally.
Awesome. That's a great question. Julia had a question. Would you like to unmute and ask, or would you like me to ask?
Yeah, I can unmute.
Okay.
So when you guys were deciding to join your research labs, like how did you choose what to join, and would you have to know a lot about, I mean, not a lot, but like about their research before joining so you can start helping right away?
Yeah, you go ahead, Gabby. You can start on this one.
I have a pretty good answer for this, or this is a very good question, because as an undergrad, I studied environmental chemistry in plants. So I studied how heavy metals accumulate in plants in systems that are designed to pull toxic metals out of the ground and into plants. And so now, because of this plant chemistry interest, I actually haven't done a lot of work in plant organic chemistry. And so as a PhD student, I've come in kind of blind. I haven't done any of the molecular biology work that I've been doing the last several months. So the short answer is you kind of just say yes to things that sound interesting and keep going. And even if you change in the middle of degrees or sort of pivot on going different directions, you kind of just like find your way and you learn as you go along.
Yeah, that's totally like, it's very similar to how I would answer this. Like you kind of have to make some changes based on like what is available in research and kind of like where the research takes you. It's never really something that you can completely predict what's going to happen. And so when I started at UC Davis, I'm a material scientist. I knew that I wanted to do something in energy, but I didn't really know what would be available to me to do that. I was like, maybe solar cells, maybe fuels, maybe batteries, parts of batteries, something like this. And then in my own department, there wasn't a lot of openings for this type of work. And so I ended up finding this group within chemistry who was working on alternative fuels. And I'm like, well, that's along the lines of my plan, but it's not something that I actually know much about. So I basically had to kind of start from scratch and learn all this inorganic chemistry that I had never heard of before. And literally for the first 6 months, it was all gibberish until I like finally was able to get some footing and understand what's going on with these molecules and stuff like this. So yeah, so it's kind of like you have to be ready to pivot to continue doing what's really interesting about the work.
I think I'll also jump in and say, you don't have to, so if you're coming in as like an undergrad in in college. You don't really have to be the expert on whatever topic that someone else is studying. I think showcasing that A, you're really excited to learn about the topic, and B, like maybe just like look up, do a little bit of reading. Like if you don't know anything about plant diseases or plant chemistry or other types of diseases or other types of topics, then just take a little bit of time to like read, like just get to know the little background of the material. You don't have to be super extensive, but just to understand a little bit so that you can ask questions. The whole point is just ask questions and understand more about this system so that you can start working on it. Other than that, just go with what you like.
And in science, it's a lot of learning on the job for sure.
And I'll add one more thing. In science, when you're surrounded by people that probably know more about some things than you do, usually, even if you know nothing about the subject and you ask a question, even if it's very baseline, if you just ask the question, everybody loves talking about their research and you'll learn something. And nobody cares if you don't know about what they're talking about, because they'll be happily tell you how passionate they are about what they're doing.
Awesome. Anya had a question. Would you like to ask your question?
Sure. I was wondering what type of like internships would be available for like a high school student or like online platforms.
I have a shameless plug for that one. So if you're based in the Bay Area, there is a institute in Emeryville called the Joint Bioenergy Institute. I'll put this in the chat, don't worry. And I used to work there. So they do a bunch of, if you're really interested in biofuels, renewable energy, chemistry, microbiology, those types of topics, then they do a summer program for high school students called iClem. And they do open applications on a yearly basis. I don't know if they're doing it this year, but next year for sure, I would look up the application. I will send it in the chat below. That's one thing you can look up. Here's the iClem program information. That's my shameless plug.
Also, depending on where you are, I'm pretty new to this area, but depending on where you are, if there's, even at community college levels, if there's university or college nearby, if you reach out to them, I bet they can find something for you to do. There's plenty of research experiences going on. I've done some that have nothing to do with what I'm interested in, just because there was space. So call around maybe.
Yeah, and also just to tack on to that, you could really just start with a Google search and then kind of based on what you're interested in, find programs for you. Most universities have some sort of outreach program for like high school students or just getting more experience to more people. And then also in a lot of cases, there's industry experience as well. For example, the company Intel has these great like summer internships for high school students where you can learn about being a scientist in industry or being some sort of engineer within industry, if that's something you're interested in as well. So along those lines, you can find stuff at really lots of different industries and universities all over.
Anya, did you have a specific topic or subject in mind, or are you just wondering as science in general?
More so like medical research, but biology too.
If you're based in the Bay Area, and you are willing to talk to people at places like Berkeley, UCSF, they do plenty of cool biomedical research. And you could even contact us to talk about it too, because sometimes you can directly email professors and ask them for internships. I'm not so sure how common that is for high school students, but it does happen. If you want to start working on medical. Sorry?
Yeah, I was just going to add to that. Along those lines, if you don't want to email professors directly, usually if you just look up departments at like department websites, and there's usually some sort of coordinator or representative there for the department that you could email and just say, hey, I'm looking for internships. I'm a high school student in this area. And you'll usually get a response pretty quickly.
I'll also add that, it's not always an internship, but if you are having trouble finding those, kind of think about what draws you to that field and get creative. Could you work with a vet? Could you volunteer your time at a hospital clinic or in a pediatric clinic, or looking for volunteer opportunities that could even be like one-offs, like one day here and one day there, helping at a blood drive, or like I said, at a children's hospital, or going to a career fair and talking to someone. Those could lead you to other places, or give you contacts that you could talk to that then could say, hey, once you graduate high school, you can get an internship, or here's another event that we're doing and you could go. Because biomedical, you might not get an internship as a high school student. You might, but you might not. And so getting creative and kind of looking for other things of that nature to volunteer your time could get you an internship in the near future. We had a question, Gabby, about what breed your dog was.
She is a super mutt. She's 11 different breeds, actually. So yeah, she's lab mix. That's what she behaves and looks kind of labbish, but yeah, 11 different breeds.
Here's a question. What is your day-to-day life? We'll go pre-COVID as a scientist.
It depends on which quarter, I suppose. I mean, a few quarters ago, it was all classes, just basically your average like college life. Like I'm going to classes, I'm coming home, I'm doing homework. But then after that portion of the degree, it's this, you kind of make a plan for what experiments you want to run, and you figure out the best way to do that, and then you're running the experiment, and then you're working with the data, and then deciding what to do the next day. And that's basically the cycle of research, at least from my perspective.
I will say that's basically what happens with me, except that sometimes those experiments will vary. Sometimes I'm in the greenhouse all day because I have tomato plants growing in the greenhouse. Sometimes I'll be in the lab doing all the molecular work. Sometimes I'll be running back and forth between those two because I have something running and I need to go water the plants. It's really depending on the day. And I usually try and plan out everything a whole week in advance, or like at least like a couple days before the week, so I can like make sure I plan everything so that I can basically do all the experiments I plan.
So quickly, I guess. So before COVID, I was an undergrad student. So I graduated in 2020. So I was mostly taking full-time classes and working on my research in the environmental science department. So my everyday life was basically classes and writing a lot and analyzing data. So the whole last year of my degree was pretty much analyzing data and learning computer languages, which is something you don't think about a lot if you think about biology, but it's very, very important. I highly recommend learning computer skills now, or starting to, if you have the opportunity, or if there's electives or opportunities to take workshops and stuff, that it's very valuable.
I also will second on that. I didn't think I would. I learned Python during college, and I didn't realize I would use it until I'm in grad school. And I do some analyses with like bacterial genomes, like with the DNA sequences of these different microbes. So, which requires a lot of computational power. And yeah, learning something like Python really helps with that. So if there's one skill I would plug, it's definitely some sort of computer skill.
Okay, here's another question. Is being a scientist hard, and does it get frustrating? Is it worth it?
It does. It does sometimes get frustrating. And it's just really because you don't really know, because everything's an experiment, right? Like for scientists, things are even more of an experiment than for your average person, because literally our whole job is to just run experiments and then understand the results of that. So if it's an experiment, the definition of that is that we don't know what's going to happen at the end of it. So then you kind of have an idea, you're like, okay, if it looks like this, then I have this set of plans, but sometimes it doesn't look like that. And then you have to go back to the drawing board and figure out, how am I going to understand what just happened and go from there? And so I guess the frustration just comes from, you're constantly getting new information and then having to completely shift what you're up to. But that's kind of the exciting part, right? Like, that's the adventure of it, is that we're constantly exploring the possibilities of what can happen.
I'm gonna jump on that and say sometimes you try a bunch of things and they don't work. So I'm gonna tell you, these past few weeks I've been running experiments and they've all turned out with results that tell me, no, this probably isn't how this works. And I think being part of a scientist is understanding that sometimes you plan a bunch of things and they just don't work. And sometimes you have to admit to yourself, like, maybe this isn't how I think the system would work. In which case, like, part of being a scientist is trying to figure out, like, okay, what can I do to present this in a way that makes sense? And even if you have to change the original plan you came up with, learning how to do that is part of being a scientist. And so it is frustrating to deal with hundreds and hundreds of experiments failing, but sometimes it still means something. It's just that in the moment it feels like you're bad at your job, but you're not. So
Yeah, that's probably one of the best things and worst things about science, is you fail a lot. And the reason I say it's the best thing is because you learn how to come back from that, and to look at failure as not failure, is to look at it as like the next step or the next hurdle. And like, that helps you with life. I mean, that's with everything. It's hard to learn how to ride a bike, right? And it's kind of scary and you're not really sure how to do it. And then you do it and you're like, wow, that felt really good. I'm glad I got through that. And I feel like there's a lot of that in science, but that's like what Cassondra said, that's what keeps it exciting. It's you're always learning and you're always growing. And sometimes that growing is hard because you're like, I don't even know what's going on, but you keep working at it. And then you're like, oh, wow, I figured it out. And it feels so good.
Hi. So for the people that just joined, thank you. This is being recorded, just so you know, and we are asking that you keep your camera off just so it doesn't lag, but please put your questions for our panelists in the chat. Thank you. Awesome. It's just a privacy thing. Thank you. Let's see. Another question that came up was, can you guys comment on navigating bad science, good science, trustworthy science, clickbait science, fake science, things like that?
So a huge piece of this is to always check your sources. You can find data or results or articles about pretty much anything. I mean, there's famous articles about how eating chocolate helps you lose weight or whatever. And you have to understand, like, where is this coming from? Is this a real study? Is this a credible, reputable source? Or is this something that is maybe not so credible? Maybe it's just an article and it's not actually based in science. So that's like one major point in this, of like, you can't base anything on a source that isn't real. And that's a huge place to start.
I also would say that as scientists, we often will propose experiments based on things that other people have done. So we don't just take one example of a phenomenon and then say, I'm going to test this. We go look at other sources. We look at other opinions and like try and compile a picture of what we think might be happening here and actually provide a ton of evidence in order to put forth a plan. So in your daily lives, when you're dealing with all of this onslaught of news and all this stuff, it's best to check multiple sources just to make sure that what you're seeing is real or what you're seeing is reliable information. You can't just look at one headline and be like, oh my God. That's been my experience.
Yeah, to add a little bit to that. Yeah, so news and headlines, right? So these are people that maybe aren't necessarily scientists that are interpreting science. And so if you've ever read even just a textbook, it's hard sometimes to understand science, right? That's why there's people that spend years and years of their life learning one thing. And so being able to go back to that source, either if it's a peer-reviewed journal or talking to, if you have concerns about something that deals with medical, talking to a doctor, not just taking, something off of maybe WebMD or your Facebook. Because there's reason those people are studying those things. They can understand and interpret the language, interpret data to kind of help you understand.
Okay, a fun question, and all the speakers can think about it. All the speakers think about their answers. Again, please add any questions you have for us in the chat. Do you have a favorite experiment or discovery, either one of your own or historical discovery or experiment that just is so cool to you and you want to share it with us?
So in my case, it was the finding that really set me on this path for doing energy science, period. And what it was when I first left my undergrad, I was working for a startup battery company, and we were playing with basically the texture of the anode part of the battery. And we found through our own data, the data of me and 2 other researchers working for this little company, that if we could change the texture or morphology of this surface, we can actually get 10 times longer or 10% longer lifespan, and then a better capacity for this battery where this anode was in this battery. And that discovery was like, oh my gosh, like we can change this one little thing and get this longer battery life, and this can affect everything. And like it's everyone's, batteries are everywhere, so this tiny discovery can then ripple out to like all these different applications. And when that happened, I was like, well, I better keep working on this because this is a huge deal. And that was one, definitely in my personal life, one discovery that really mattered, which was very cool.
I don't know if I have a favorite experiment, but I will share something interesting that I've learned in my classes. So bacteria have all sorts of mechanisms in order to defend themselves from other bacteria. Like they can make toxins, they can make poisons for other bacteria, and they can protect themselves from other bacterial toxins. But I think one thing that really stood out to me was that bacteria can make weapons, molecular weapons. There's one really interesting thing that microbes can create. Bacteria can create really tiny knives that can poke into another bacterial cell and then inject toxins directly into the cell and destroy them. And I just thought that was so interesting because you never think of a really, really tiny organism being able to wield a weapon and stab something. It's violent, I know, but it's just so strange. And I just thought it's really cool that someone was able to discover this and be able to figure this out in real time, because again, it's so darn small.
I'm having a hard time with this one. So I can't think of anything directly, but in general, I really like experiments that are just simple. And like we have all this really cool technology and stuff right now, but like when you think back at some of the experiments, gosh, and I wish I had an example right now, but even some of the like older plant experiments where they're like, okay, we know that the plants grow up, right? Well, what happens when we put the light over here? Oh, the plants go this way. Okay, what happens when we put the light over here? And just some of the most amazing discoveries were just made from just kind of like tweaking little things in your environment and just like asking little simple questions like, what happens if we do this? And I just really think that those experimental designs are just so beautiful sometimes and simple, but they lead to some really epic discoveries.
Awesome. So Ina Muri, I'm sorry if I mispronounced your name, had an astrophysicist question for us. Would you like to ask the panelists?
Sure. My name is Lohit, and my question is like that. If the sun and the moon are right behind each other, isn't the moon supposed to burn? Why isn't it burning? And why didn't astronauts die when they went there?
I don't know a lot about astrophysics, but I think that the sun is really far away. So I think the moon is a lot closer to us. That's why we got to go there. And then the sun is still so far away that it's not hot enough yet. But that's all I know.
To put it in perspective, so I minored in astronomy. So I know a little bit about astrophysics, actually. I did take a course called astrophysics, so I got you. So the sun is what we call 8 light minutes away, which means that light leaves the sun and it takes 8 whole minutes to get here. The moon is much less than that, actually less than 1 light minute. And the moon doesn't emit light, but it does reflect light. So basically the path of light is coming from the sun, and then it hits the moon, and then it reflects off the moon, and then we see it. The moon is reflective because it has aluminum in its composition, and aluminum's shiny, and that's why it reflects the light. So when you see an eclipse, you're seeing that the moon is in front of the sun, and the distance between the sun and the moon is actually much further. And that's why the moon does not get toasted up. It's actually colder there than it is here because it doesn't hold on to that heat as much as the Earth does. So yeah, that's why. And also astronauts were able to go there because it's actually a fairly decent temperature. I mean, obviously they were in suits, but they were able to be there and not freeze to death and not burn to death because it's actually a decently habitable temperature as long as you have a nice spacesuit on.
Wait, Cassandra, I actually have a follow-up question for you. So do you happen to know if there's any sort of like UV risk? Like say, like obviously the suits are meant to protect the astronaut from that sort of thing. But like if you weren't wearing that suit, would you get a really bad sunburn?
Absolutely, yes. And the reason for that is because the moon does not have an atmosphere. The Earth has this pretty huge, 7-mile atmosphere that is composed of mostly nitrogen, obviously oxygen, carbon dioxide, carbon monoxide, all these great gases. And that is basically forms a nice little shield for us from the UV, and like clouds and moisture in the air protect us. And on the moon, it has none of that. And so it's getting the sunbeams like direct to the surface of the moon. So yes, there is some UV radiation risk, which is why we would need suits, or if we were to terraform the moon, we would need to produce an atmosphere that could then protect us in the same way.
Thanks.
I hope that helps, yeah.
That was a great question, and I think some of us also learned stuff. So thank you for asking. Anya, you had another question. Would you like to ask the panelists?
Sure. I was wondering, when you're working on like a project or experiment that goes on for a long period of time, do you find it hard to like stop thinking about ways to solve it when you go home to like your family or your social life or anything? And does that get in the way?
Yes. My roommate and I have said I had a dream last night of the experiment we were working on. Yeah, it definitely is tough to leave it at work, and a lot of times you do end up working on it from home or planning something from home. But at the same time, you're only so interested in it because it is so interesting to you. So I think that it's not always a bad thing, but you do definitely have to make sure you are taking enough breaks and taking care of yourself, and whatever your self-care, relaxation, hobby, or whatever it is you need to have that time also at home so that you don't just go a little crazy.
Yeah, I would say that some people learn to really separate, like, for example, like I don't really talk about my experiments with my family. Like my brother does not want to hear about plants getting sick, period, which is okay because, he's a computer scientist, he can deal with his own stuff. But I do have friends and colleagues at school that I sometimes will talk to about my experiments because it's like, oh man, I'm dealing with this problem. This is awful. And they help you kind of pull yourself out of your head for a moment. And they'll tell you things like, look, to put this in perspective, you're doing all this work, even if it turns out badly, like it's okay. It's okay. So I think it's good to talk to other people about this stuff, but also like it's nice to have people that you don't have to talk about this stuff with. I think having that separation is essential.
Yeah, I agree. The separation of, work and play, but like Cassandra said too, when you're really passionate about what you're doing, it's fun to talk about, and you kind of surround yourself. I mean, I definitely have friends that aren't scientists, lots of friends that aren't scientists. In my family, my husband is not a scientist, but it's fun to communicate science even with people that aren't scientists. And so I do talk about challenges that I have in science, and sometimes you'll even get really good perspectives from those people, so because they think about things differently than you. But yeah, I think that with any work that you're going to do, hopefully you're doing some work that you love. And so if it does leak a little bit into your home life, then it'll still be enjoyable.
Awesome. So we have just under 10 minutes left. So again, ask your questions. I think we'll kind of stick to that topic of work-life balance. If you're unfamiliar, it comes up all the time. And I think most fields, but especially as grad students, we talk about it a lot. And so do the three of you either want to comment on hobbies you have outside of science that scratch your science itch but aren't research, or tips and tricks that you have to keep your work-life balance? If you find yourself working 12-hour days, what do you do to reel yourself back in and make sure that you have time for your hobbies?
Yes, you are very correct that it does come up all the time. And the thing about a grad degree is you're kind of in charge of your own time. So it's really easy to overwork because you're the only person who's controlling your schedule. So you're like, well, I want to get this all done. So you start like just spending, like you said, like 12-hour days doing this work, and you can't do that. It's not sustainable. It's not healthy for you. So one super great method is just to have a set cutoff time where you're like, I must stop, I must shut off the computer, I must close the laptop, whatever it is, at this time every evening, and make sure that you have time for things that you actually love, like that are hobbies. For me, I've been practicing ballet. I actually am working towards becoming a point ballerina. And so what I do, and during the pandemic, I can't go to classes. So I've been taking these like video ballet classes in my apartment with my point shoes on, trying to learn and continue to train for ballet. And so, shut off the computer, put on those shoes, take your class. And I also, on the weekends, I love to read fiction for fun, and I love to hike. And those are like my main things. Like if I'm outdoors, if I can have both in one day, I'd go for a hike and then read at the peak or something. That is like the perfect day for me. So I always try to make like one day a week that's just like that, where I like get to go somewhere nice and just have a chill, relaxing, no research kind of day.
I think you covered it with the balance, finding something, making sure that you take time for yourself with anything. A graduate degree is hard. Working is hard, but making sure that you recognize your hard work and take the time that you need to make sure that your brain stays happy. I like to hike as well. I spend a lot of time outside walking my dog and hiking. I hike every weekend if I can, especially now that I'm new to the area. I've found a lot of new places, so that's fun. And then biking with my son. We like to bike a lot. So yeah, going outside helps, especially in today's Zoom world when a lot of your work is like in the same room. It helps to go outside.
Definitely.
I think for myself, like, if I can't set like a cutoff time to stop work, shut down the computer, I at least try and take a step back and say, what is the thing that I absolutely need to get done today? Can I get this done? If nothing else, can I get this done? and everything else is like great if I have the energy, and it's okay if I don't. So that way you can at least like temper your expectations throughout the week so that you don't end up being like planning so many things and then you just don't have time for half of them and you just sit there being like, oh my God, I didn't fill out my to-do list. I'm so stressed out. So I think just being aware of what your priorities are, and that's a thing that all students can relate to, just setting priorities and thinking like, I need to make sure this comes first and then this comes first and then these stuff can come if I have time. And like everyone else has been talking, like many of us have hobbies outside of lab. Like as you can see with my Zoom background, I draw a little bit. I also have been learning how to play piano, which is really hard. I played clarinet when I was younger. Piano is totally different. 2 hands, yeah, that's a little, it's a lot. But so for all you kids out there who can play piano, good on you. That takes a lot of discipline. But yeah, it's just nice to put yourself in a different, just put yourself out of work for a little bit, take the time to recharge, come back to it feeling refreshed. That's another way to think about it too.
Yeah,
Awesome.
I like the point
So
about
sorry, Cassandra, we have 3 minutes left and Logan had another question, if we can get that in. And then Cassandra, can you type into the chat what you were about to say?
Oh, sure. Yeah, totally.
My question is that like, how does a skeleton grow if your skeleton is like hard as a rock?
Okay, I can stuff in here. So this is actually an amazing question. Basically, our skeletons are made out of whatever elements were available at the time of our basically evolution. So if you look at the composition of just the earth, right? The like most abundant, the thing that we have the most of as far as hard minerals is calcium, sodium, potassium, magnesium. These are like white kind of powdery like rock-like minerals. And so that was kind of the easiest thing that was around when humans needed to build bones. And so that's what we've built bones out of. And basically we have this evolution that allows us to have these hard structures inside of our body to keep us upright and able to move around. Now, if we lived on a planet where there was more, say, titanium or iron or any of these like really intense metals, titanium would be crazy, then we would have bones made of that. They're much more structurally sound, they're much stronger, but we just don't have enough of it to have in our bodies. So yeah, it's pretty interesting. It's fun to think about, you know, in another universe or something that like we'd have these like super metallic bones and like super strong muscles because we have to carry these big bones around. But that's just what we have based on where we're from.
Beautiful. Cassie coming in clutch with the physics and the nutrition. So that's our time. Again, Cassie, was there something quick that I cut you off that you were saying?
No, I was just gonna mention just, you know, to not worry if you don't meet your to-do list, to never be hard on yourself, because it's the fact that we're all trying that matters.
Yes, second that. So again, thank you all for coming. I've left our website and our email in the chat if we didn't get to all of your burning questions. And we hope that you enjoyed the session of Discovery Day. Thank you to our panelists for joining, and thank you to all of you for coming and asking our questions.
Thank you, panelists. Very good.